Hello everyone. In this video we're going to talk a little bit about factoring and how it's related to the graph of a function. What information we can get from factoring and how if I know the factored form, how can that inform my graphing, and if I can see the graph of a quadratic function, how might that help me factor. So the place that we're going to start is by talking about something called the zero product property. Okay, so the zero product property, written this way. Okay, so the zero product property. It tells us that if I'm going to multiply two numbers together, or two terms together, say a times b, and get a result of 0, so we'd say if a times b is equal to 0, then the only way that that can happen is if either a is equal to 0 or b is equal to 0. So if I'm going to multiply two numbers together, then if the result is 0, one of those two numbers had to be 0. So I can't multiply two non-zero numbers and then get back to 0. So this is actually very helpful because it tells us that writing things as multiplication could be very much to our advantage. Now if we think about this form right here, a times b, that's what we're doing when we're factoring. We're taking something that's not written as a product and then we're turning it into a product. We're turning it into multiplication, so then this zero product property could apply. And so this is a very, very powerful tool for us and something that we rely on, and it's one of the big reasons why we factor. So to give us some concrete example of what's going on here, I'm going to give us a function. All right, so let's take an example. F of x equals x squared plus x minus 6. So if I want to know when this function is equal to 0, or what the zeros of this function are, then in its current form, I don't really know. I don't know what I could plug in to potentially get 0. But if I can factor it, if I can write it as a product, then the zero product property is going to help me out. Now, back to our knowledge on factoring, we saw that if I'm going to factor this into the product of two terms, what I can do is I can think about finding numbers that multiply to be -6 and add to be 1. So there's no number here, but it's assumed that this is a 1. So if we're multiplying by 1, we don't write it. So this would be a 1x. So we're going to ask ourselves two numbers that multiply to be -6 and add to be 1. Right, so I'm going to pause for a few seconds. So if you want to pause the video and think about this before I write it down. All right, so the answer to our question, two numbers that multiply to be -6 and add to be 1, are +3 and -2. Okay. So if I think about this, x plus 3, x minus 2, if I were to FOIL it out, I would find that I do get what I want. So this is the correct factored form. Right, so we're going to go back and see, well, maybe I'm interested in asking the question, when is this thing equal to 0? So we're not always interested in zeros, but a lot of the time we are. And it's one technique that we have to solve quadratic equations. So I'm interested in this equation right here. X plus 3 times x minus 2, when is that equal to 0? Well, if I make the connection, if I make this connection right here, these things look very similar. I'm multiplying two things together, a times b equals 0, and down here I have x plus 3 times x minus 2 equal to 0. So the zero product property tells me one of two things has to happen. Either x plus 3 is equal to 0, or x minus 2 is equal to 0. Okay, so either x plus 3 is equal to 0, or x minus 2 is equal to 0. And then if I rearrange these things, by subtracting 3 from both sides, this tells me that x has to be equal to -3, or x has to be equal to 2. So in the case when I'm interested in determining the zeros of a quadratic function, factoring is a very powerful tool for me. Right, so what it does is it allows me to use this zero product property and take something that was one big piece, right? So I had one big piece here, and break it up into two more manageable pieces to get my answer. Right, so what I'm going to do is I'm going to pause our video here. I'm going to bring up Desmos, and we're going to see in Desmos this example and how the factors are related to the zeros in our graph. And we're back. And what you should see in front of you is some of the work that we did before. So we had a function x squared plus x minus 6, and we factored it into x plus 3 times x minus 2, which told us that the zeros were x equals negative 3 and x equals 2. So what we're going to do now is we're going to plug this into Desmos. So I've already done that for us here. So we see this in Desmos. And our graph is this nice parabola. And what I'm wondering is, where do I see this information? How can I verify that the zeros of this function are in fact negative 3 and positive 2? So what we have is, if I highlight, so if I come over here and click on my function, which I already have, you'll notice that in Desmos, there are a couple points that have popped up. So I'm going to go ahead and click on them so they give me coordinates. So there's these 2 points here where my graph crosses the x-axis. So these points are the visual representation of what we call the zeros. So these are the inputs that correspond to an output of 0. So what I want to know is, if my line, if my graph, my parabola, if it crosses the x-axis, what are the x coordinates of those points? And so if we see here, this point negative 3 comma 0, it does in fact correspond with us having a 0 at x equals negative 3. So we'll have an output of 0 when x equals negative 3. We'll also have an output of 0 when x is equal to 2. So from a graph, if I were to see this graph and I figured out what the zeros were, that could actually inform how I can factor my quadratic equation. Now, if you are factoring, if you're trying to find the zeros, Desmos is a nice way to verify this. So plug your graph into Desmos, and then it should highlight the points where it crosses the x-axis. You can highlight them and verify that your answer is correct. All right, so I'm going to go through one more example where I'm going to give us a function, and we're going to look at the graph, and we're going to see if we can use the graph to write out the factored form of our quadratic. All right, so I'm going to clean this up, and then we'll be right back. All right, and we are back with a new example here. So I have a function, I'm calling it f of x equals 2x squared minus 7x minus 4. And if I'm wondering, how do I write this in factored form? This is an interesting example for me because we have a quadratic where our leading coefficient is not 1, it's 2. And so some of the examples in class, this gave us some trouble. So let's go ahead and see how looking at the graph of this function can inform our information about some of these factors. So if I look at my graph, what we saw before is I'm very interested in my zeros, and it turns out here that 2 of my zeros, they look to be 4 and negative 1/2. So 4 and negative 1/2. Well, what I would want to do is I want to build a new polynomial to see if I can write it out in factored form. So I'm going to try to write out a factored form here, and I would have like x plus something here, and x plus something else over here. And I'm wondering, if these things are going to be zeros, how do I get negative 0.5 and 4 to be zeros of these things? Well, I want to know, if I plug in 4 for x, I should get a 0. And so to go from 4 to 0, what I would have to do is subtract 4. So I think if I make one of these things x minus 4, then plugging in 4 will give me a 0. So that looks good to me. And if I'm going to plug in negative 0.5 and get 0, then I think x plus 0.5 should be okay. Oh, okay, so we have a blue line. I'm going to go ahead and I'm going to turn off our red graph, just so we look at this x plus 0.5 and x minus 4. It looks like I have another parabola that goes through the same 2 points. So this is kind of interesting to me. If I turn on my red line again, I can see that they're different. So it turns out that knowing the zeros, just if I know the zeros of a quadratic, it's not quite enough information for me to factor. But lucky for us, if I think about this, it turns out that if I were to go through the foiling process, I would get x times x, which is x squared. And that's not what I want. I actually want 2x squared. So if I'm thinking about it, and if I'm clever, if I just multiply everything by 2, maybe that will fix my problem. Maybe that will do it. So if I multiplied everything by 2, it seems like the red line and the blue line are actually the same. So if I turn on the blue, you can see that that's here. And if I turn off the blue, we can see that it turns into red, and so they're the same. All right, so knowing a little bit about my function, if I know what my leading coefficient is, it turns out that if I know it's a 2, and I know what my zeros are, that's enough to inform me how to factor my quadratic equation. So this is part of an exploratory video, and what we're going to see when we move into polynomials, we're going to see more formally how the factors of a polynomial are related to the zeros, and how we can do that. So this is setting us up for the future, and I hope this gives you some insight into the connection between why we factor and how we can use graphs to help us factor, and how we can use factoring to inform our graphing. So in the next video, what we're going to explore is this point down here. So it seems like there's this nice point on parabolas that is sort of at the bottom, or maybe sometimes it's at the top, and we call it the vertex. So in future videos, we'll talk all about the vertex and what information it gives us about quadratic functions. All right, so I'll see you then.